Okay, in today's lesson we are going to learn the crisscross method. This is going to be the way that we write formulas for ionic compounds. Before we start, I need you to find the worksheet that's on the left side of your screen called Writing Formulas, Crisscross Method. Once you have that, you can resume this video, and I'm going to work some of these problems with you as examples, and then you'll practice the rest on your own during class. Alright, let's just start out with the first one. All the cations, remember, are going to be written first in an ionic compound. So the cations are listed down the left side of the page. We're going to start with sodium, for example. And then on the top side of the page are all your negative ions or your anions. And those are going to be written second in each one of the ionic compounds. So I want to start with the combination of sodium and chlorine. Alright, so I'm going to write sodium first, Na with its +1 charge, and I'm going to write Cl with its -1 charge. Now the way that the crisscross method works is that you are going to take the charge of the positive ion and crisscross it down to where the number will sit beside the negative ion. I'm going to do the same thing with the negative ion's charge. I'm going to crisscross it down so it sits next to the positive ion. When you do that, you get Na1Cl1. Now notice that the positive and the negative has disappeared at this point. They're just numbers. And really with ones, we're going to let those be understood. So I'm going to reduce it even further, and I'm going to put my final answer over here. It's going to be NaCl. So the final answer here is NaCl. And those ones are just understood. The next one that I want to work with you has a polyatomic ion in it. Let's do the potassium K. Come over here and write the K+1. And I'm going to combine that with sulfate, which is SO4, with a -2 charge. Now with that crisscross method, we're going to do the same thing. This +1 charge is going to crisscross down and sit beside the 4 in sulfate, and the -2 with sulfate is going to crisscross down and sit beside the K. When you do that, you're going to get K2, remember the positives and negatives disappear at this point, SO4, and then a 1 is understood, so I'm not even going to write it at that point. So I'm going to come back over here and fill in. Alright, let's try one more. I want to try one now that has a parentheses in it. So I'm going to choose to do calcium +2 and phosphate PO4 with a -3. Ca +2 and PO4 -3. Anytime you write a number next to a polyatomic ion, you want to put it in parentheses. And so this is going to be the final answer for this one. Let me come back over here and write that final answer. So just remember to use the parentheses anytime you're putting a number next to that polyatomic ion. The final example that I want to work with you is the magnesium here with the carbonate here. So let's do our work on this side. I'm going to write down the positive ion first, magnesium, which is Mg. It's got a +2 charge, and then CO3 is carbonate. It has a -2 charge. The crisscross here is easy. The 2 from magnesium sits beside carbonate, and the 2 from carbonate sits beside the magnesium. So when the positives and negatives disappear, I get Mg2, CO3, I need those parentheses, and another 2. Now that does follow the rules for crisscross, and I've used my parentheses, so it seems like that should be the final answer. But I want you to make one quick note here. When you write your formulas for ionic compounds, they need to be in lowest terms. So when you look here, I have 2 magnesium ions and 2 carbonate ions. That can actually be simplified. Those 2's will reduce each other away, and you can end up writing as your final answer just MgCO3. And because those 2's have disappeared, I no longer need the parentheses. So my final answer over here on this side, I'm going to fill that in the blank. So the things you want to remember about doing this crisscross method is the positive ion comes first, the negative ion comes second, ones are understood, use parentheses after a polyatomic ion, and finally reduce to lowest terms. The main reason that we use this crisscross method is because it allows compounds to be neutral. If you look at the charges that we start with and how many of each ion ends up in the final compound, what we're doing is making all the positive charges from the cations equal to all the negative charges of the anions. So when we write a final answer for an ionic compound, it's a neutral formula, which means it has a charge overall of 0. So hopefully that'll get you started, and we'll be able to do a lot more of these in class. So if you get stuck on any of them, have no worries. Just bring all this with you next time. Thanks. Have a great one.